What's up, guys? It's Ben from Esquewire. Today I'm going to show you how I made this wireless phone charging dock. Weirdo. So, I had a problem. I have lots of problems. There's not enough time for me to enumerate them here, but one of them was that my phone's USB port died. It means I can't charge my phone that way. So I had to adapt. I got a wireless charging system. This specific one that I got is by Ubio Labs, Ubio Labs. Oh, I had them at Costco, so that's what I got. They're pretty good. They're pretty solid fast charging. But my problem was that I would set my phone down on these at night when I'm going to bed, and my phone would land on it right. I'd get it lined up just right to it makes the noise, lights up, it does its charging thing, it lets me know. But somehow, over the course of the night, me or probably my pets would bump the phone just a little bit. And then I wake up to a completely dead phone. That happened enough times that I figured I needed a solution. So I came up with this, which is my first version of the wireless charging puck dock situation. I made this by modeling my phone and the wireless charging puck in Fusion 360, and then I made a block of wood and sank those two things into it to get that shape, and then I split this shape into a shape that could be cut out of plywood. This is actually only 1/2-inch thick sheets of plywood that are glued together and held in line with these registration pegs and dowels that I have in the corners. So I split it up into two pieces and then sent it to the CNC, got it all chopped up and then glued up, and here you got the first version. And this works great. Without my phone on, without my phone case on, I can just set my phone in. It just settles right into the slot. You hear the boop, the charging, you're all good to go. You know it's set. Dogs can't move. Well, the dog could move this if they really wanted to, but this does prevent, the odd accidental bump. So it's pretty successful, so much so that I found myself bringing this one into the Makerspace here, into my office. It's not quite an office, it's off-ish, into my office to charge up my phone. And it's just kind of a hassle to drag that thing. It's not as convenient as a USB cable. So we got to make another one. So that's what we're going to do. I already have the model drafted up in Fusion. I'm just going to make a couple tweaks to it to make it a little better. And then we're just going to head off to the CNC and get this thing put together. So come on, come on, come on. All right, I'm definitely going to have to ask that guy to tone it down, because that's a bit much. Okay, so once we're in Fusion, these are the pieces. The couple of changes that I wanted to make was the little curvy bit at the bottom of the wireless puck socket was giving me grief. It would be easier if I just made those straight side. So I expanded the circle that I originally made it with and then just extruded that shape up to cut it into a perfectly smooth cylinder the whole way around. Ah, yeah. Smooth. Doesn't look quite as pretty, but it's a lot easier for the machine to cut, and it will hopefully interface a lot easier with the charging puck. Next, I just wanted to give it a little extra depth because it was poking out a little bit too much out of the top, so I dropped the bottom of the socket down by 1/10 of an inch, and hopefully that'll be good. If it's not, we'll just change it, make a new one. And then these two pieces are pretty much ready to go. We just swap over to the manufacturing tab in Fusion 360, which allows us to generate what's called G-code that tells the CNC specifically what we want it to do to cut the piece we need. And you can see mine's a little mad at me. I got a lot of red errors. That's because I changed the geometry that a bunch of the previous operations were based on. So if I come back in and fix those and adapt it to my new geometry, then they should be all ready to go. One of the really handy features of Fusion 360's manufacturing settings is that it can allow you to pre-visualize what the actual CNC cut will look like, and it is surprisingly accurate. I'm going to pull up a couple shots side by side through the course of this video to show you what I mean, but this is basically just a brief rundown of how the operation is going to look. We drill out the corner holes, it'll carve the pockets, and then it goes into the contours, which takes a fair bit of time, as represented here by it taking forever. Yeah, so you can see all of the cuts you're going to make before you make them, hopefully allowing you to see any mistakes before it's carved into really expensive plywood in my case. Or if you're using actually expensive wood, then you could drop the sarcasm there. Then we just compile those onto a flash drive, bring them over to the CNC, and bada bing, frickin' bada boom, we're off to the races. And as I arrive to the CNC, it must be my birthday, because look at this almost perfectly flawless spoil board, except for this. Who did this? Who did that? I want to know. In order to get started on this sucker, just gotta flip the switch. This CNC is such a model that when you power it on, the spindle head comes forward to greet you, drops down lower, and then does a bit of a threatening dominance display. It's kind of a territorial thing. It's letting you know that you're in its turf. No, I'm kidding, that's me steering it. First you zero the CNC, which is where it moves along all of its axes until it reaches the far corner so that it has an indexing point called referencing. I just move the arm out of the way, mount my material. You can just use blue painter's tape and a little bit of CA glue or crazy glue. You put painter's tape down on both surfaces and then glue between, and that holds it nice and tight. That way if any pieces get cut free by the CNC, they won't fly away. They're still stuck to the table. This is just some activator that speeds up the super glue's adhesion rate from 30 seconds to like 3 seconds. Yes, I'm that impatient. And all of us are, okay? I'm not the only one who uses that. These are the 2 bits that we're going to be using today. We can get the whole operation done with just these 2 bits. This is a 1/4 inch compression bit, which is really good for plywood. It helps prevent tear out, giving us nice clean edges. And this other one is a 1/16 radius ball nose tapering end mill, which is super fun. It's got that taper, means it's nice and strong, a lot less likely to break. Due to the rounded profile of the tip, it can carve all sorts of angles and curves. And that's exactly what we're going to do to get the radius in the finger grip area of the foam dock. Every time you change bits, you have to engage in my absolute favorite operation in CNCing. It's beautiful. A circuit is completed. It digitally understands where the surface of your material is so that it can properly cut it and not into the air. And then it's off to the races. First we carve the 4, or 8 rather, registration pegs. Do forgive the smoke and steam. I need to mess with the settings. It should not be sending flaming things around. Then we carve into the pocket. Alright, another tool change. We're going to swap over to that tapered bit. And guys, listen, I'm a budding videographer, okay? I didn't know how to control the autofocus on the situation, and it fell a little bit in love with this piece of art in the back. So maybe that's a good time to talk about it. This was made by a dude at the Makerspace, Trevor, on the CNC, using a program called ArtCAD, I believe. Pretty cool. Ripples, carved 3-dimensionally into plywood. Pretty neat. I can see why the autofocus liked it. Oh. Oh. Ugh, love it. This is by far the longest single cut operation in this entire process. But here we can see some interesting stuff. This really tickles me. This is how close the previs on Fusion is. Look at this. I tried to get the exact same shot. Man, this just tickles me. Everything, the little notch in the puck in the center, it's all there. The way that it depletes away over time, really cool. So here's an interesting problem that occurred the first time I made this, that occurred the second time I made this, but I knew about it the second time. This giant block is only being held in place by just two of these tabs. There's one here and one on the other side. And as the tapered bit comes around trying to carve this profile, it's going to carve the profile all the way down to the table. So do you see a problem here? I didn't the first time. The tapered bit is going to carve away all of this tab, which means that at that point, that puck will just be free floating. If it wasn't for the tape and glue. First time I did this, didn't have tape and glue. Puck came off, got stuck in the CNC machine, caused a lot of smoke. It was a big deal. Don't do that. But this time, no problems. It's very glued down. And then the last cut that we need to do is 2 passes on each side to fully cut them out from the stock. We've got to do 2 passes because my bit is only a 1/4 inch in diameter, and you can only go down into a material as deep as your bit is wide. So if I have a 1/4 inch wide bit, I can go 1/4 of an inch down, and since this is 1/2 inch thick material, it takes 2 cuts to do. You could do it in 1 cut, but boy, it would be screaming at you. It would be really mad, and you'd probably break a bit. Better not to do that. And because we did it right, check it out. Puck stuck in the center, didn't fly up into the CNC. The cleanup of the tape method is a lot more than using clamps, but it is way more efficient in my book, and it very seldom... Oop. Got a little bit of super glue hardened tape under my nail. That hurt, but luckily we have first aid kits, so I can get right back to work. And here are our 2 pieces fresh off of the CNC. We just need to grind off these tabs, but they seem to fit pretty well together. So that means our measurements were right and our cuts were right. Next step. Alright, now we've got to address the issue of the registration holes. I made these so that we could make sure that both halves were lined up perfectly and were glued together right, but in order to take advantage of that system, I have to cut a dowel into 4 pieces and insert a piece into each of these holes such that it holds it steady. Now I bring this over to the vise, and it's really important when using a handsaw that you use the wrong side several times and then find out that you're supposed to be using the cross-cut side. This is my saw, funny enough. Nice, I don't know how to use it. There we have our 4 pegs. I'm going to take them back over to the belt sander, grind off the edges so that we just have rounded profiles that can be hammered into place. Boom. Well, that was Yeah, you're in a communal space, Ben. One last measure just to make sure that they still fit and they haven't grown or shrank. I did notice a little bit of a scuff in the front of the piece, but I don't know. I'm not trying to impress anybody. We take some glue, what would probably amount to too little glue, slap it in between the pieces, smudge it around a bit. And then I get it mostly lined up. And I take these pegs, I just spritz a little bit of glue on the end. It's not really necessary. It's such a tight fit that the glue, most of the glue is going to squeeze out anyway. But it's just a nice procedure. We just give it as much of a wipe down as we can here. Get all the excess smudginess. Which leads me to believe I might not have had too little glue. The one last thing that I need to do is bore a hole in the side for the charging cable to come through. Thankfully it doesn't charge by a USB, it's a little round 5-volt plug, so I can just take a slightly bigger than 1/4 inch drill bit, I don't do fractions, and bore through here, and then we can just lead the cable on in. And once we've done all that, we end up with this. Haha! Not too bad. It's just slightly better than the original, which was the intention, so that's a total win as far as I'm concerned. And now I have a place to charge my phone at the office, so that's also a plus. Yeah, so thanks for tuning in, guys. And as per usual, none of this would have been possible if it wasn't for Pikes Peak Makerspace. They're a makerspace in Colorado Springs, 60,000 square feet, donation-based. They work entirely on volunteer labor. So if you've got a minute, check out their site. I left a link in the description below, as well as a link to their donation page. No pressure, but if you got a spare dime, sling it to them. Nobody's making any money from it. It's just to keep the makerspace running and to keep people making and creating. So yeah, cheers for that. Thanks for tuning in, guys. Don't forget to subscribe and like this stuff and this stuff. And we'll see you later. All right. Goodbye. I shouldn't kiss. Don't kiss. I'm not going to kiss. All right. Goodbye.